Hello, guys. Hello, world. Hello, Philippines. Hello, everybody. Welcome to my YT channel. So, we are now on the problem solving of the transfer. Okay, we have three problems here. But you are not lucky today because we don't have a pencil. I'll check first. Okay. I'll have pala siya. Okay, I will read the problem first. Okay. Problem number one. Water at 4 degrees Celsius is having a viscosity of 1.5673 millipascal second. Flows through a horizontal pipe with a cross-sectional area of 4 square meter with a velocity of 5 meter per second with a pressure of 300,000 Pascal at point A. Okay. At point B, the cross-sectional area is 2 square meter. What is the velocity of water at point B? Bongga. Letter B, calculate the pressure at point B. C, calculate the Reynolds number. D, determine the total volume of the feed in the pipe. Determine the total volume feed in the pipe, and then what is the length of the horizontal pipe. Oh my gosh! Talaga? So there are one, two, three, four, five, six questions in one problem. Imagine. Okay. So this one. I don't have to put again because it will take time, right? In this live stream. So all we have to do is to uh, follow the steps of solving problems, solution like this. Okay, and we need to illustrate first to understand very well. Okay, like that. So we have horizontal pipeline. This question number one, right? Okay, horizontal pipeline like this. Okay. So as you can see, the area decreases from 4 square meter to 2 square meters, so a little bit reduced the area. Okay, so like this. So look at this pipeline. This is the pipeline that we are referring to for this particular problem. Okay, and then the water flow here. Let's say this is point A here, and this is point B here. Okay, something like that. Okay, point A and point B. Okay, so the water flows there, the inlet. Okay, and the velocity of the water at the point A is, we'll call this as UA. So UA is just velocity. A is in the given we have 5 meter per second. Okay, like this. Velocity. Okay, and then we have the area of A also, which is this. This opening here, right? This is a cross-sectional area. Okay, so we have the, actually this is pi squared over 4. Okay, but we are not dealing with that. We're just taking the area. Okay, so area is equals to uh, area A, ganun, ganun. Okay, this is 4 square meter. Okay, so we need to input all the given as much as we could, right? So this is only water. This is not an issue, okay? Because this is a pure substance, okay? So there will be no issues with other physical properties and chemical properties. Okay. Now we have the viscosity. So if that is not specified in our problem, what kind of viscosity, just treat that as an absolute viscosity or the dynamic viscosity. Okay? And you can also really identify if it is a kinematic viscosity or absolute viscosity because of the unit. Okay? The unit here is Pascal second or millipascal second. So it is understood to be absolute viscosity. Okay? Because later we will be computing the Reynolds number. And the Reynolds number needs the absolute or dynamic viscosity, but don't need the kinematic viscosity. Okay? Don't be confused because the unit of kinematic viscosity is square meter times seconds negative. Okay, but here it's not like that, so don't use that one. Okay? So viscosity. Okay, let's have this as mu. Okay, mu or micro, something like that. The symbol only have. Okay, so 1.5673. Okay, Pascal second. Now, guys, I want you to memorize this. That we can come up with the density of water because we need this density also somewhere along the way. Okay, because momentum transfer needs really the density. Okay, for the formula in the first place, right? You can remember our momentum transfer, the flowing flow. So we need to discover the density. But in this case, class, there is no specific density given. Okay, but in this situation, if no density given, we need to treat that as the standard. Okay, so the standard is at 4 degrees Celsius all the time, all over the world. Okay, it is always at 4 degrees Celsius of water to achieve 1 grams per ml of density and to achieve 1,000 kilogram per cubic meter. Okay, like that. Or to achieve 1 gram per cc, like that, cc or cubic centimeter. Okay, you can convert that one also to make sure, maybe I'm wrong, but try to convert 1 grams per ml to in terms of cubic centimeter. Okay, so that would be your standard in terms of cubic centimeter density. Okay, because the volume is always at the denominator. Okay, because some books also stated there cc only. Okay, but that's understood to be cubic centimeter. Okay, but it is 1,000 kilogram cubic per meter. Just memorize. Okay, 1,000 kilogram per cubic meter because this is the metric unit of the density of water, especially in momentum transfer and fluid flow or fluid mechanics. But it depends on the problem, but usually metric system is used. But if you can encounter also a problem with using the English units or the SI, then go for it. Okay, the pound, the feet, like that, minute, or whatever. Okay, I'm just telling. Okay, so our absolute viscosity, or just we just treat this as a viscosity in this problem, huh? Forget the kinematic viscosity. Okay, 1.5673. This is millipascal per second. Okay, again, hello guys. Again, this confuses the small letter m and the big M. This is milli if small m. Okay? Like that. This is milli if small m. Okay? If big M, that is mega. Okay? Let's agree. Because it's just the same. M. Capital M, mega. And small letter m, milli. Okay? Coffee is life. Charot! Okay? Ganun siya. Oh my gosh! Nag-spill yung coffee. Charot. Okay? Then, convert first the millipascal, this one, the viscosity, because we don't milli something in the solution later. Just convert directly to make it sure. Ganon. Okay. Times, okay, like that. Millipascal is equals to 10 to the negative 3 Pascal. Okay, just like this. Okay? Because that is negative 3 only, the milli. Okay? The micro is negative 6. Okay? Then we need to move at the right because this is exponential. If negative, move to the, no, not to the right, to the left. Okay? 3 decimal places, something like that. Okay? So 1, 1, 2, 3. So 0, 0, 1, 1, 5, 6, 7, 3. So this become now Pascal second, in which this is a unit of our absolute viscosity. Okay? Pascal second is a unit of absolute viscosity, or this is just equal to kilogram per meter second. Okay? Or equal to Newton raised to the power 2 times S over M. Again, never mind the Newton, okay? Because we will not use the Newton really, okay, for this moment in time. Okay, because it's something Newton times second over square meter, ganon. Okay? Just forget that here muna ha. Okay. Then, the velocity B here also. If you have the B, the A points, the B points also. So the B velocity is, so UB is equals to 5 meter per second. And then our area changes man siya. Okay? From 4 siya, naging ano siya, 2 meter square meter. 2 square meter. Okay? Like that. So area B, 2 square meter, like this. Okay. Now, the viscosity is just the same that will flow inside the water, and also the density is just the same somewhere along from point A to point B. So we don't need to have another value. Okay? So density is equal to 1,000 kilogram per cubic meter, again at 4 degrees Celsius. If it is not mentioned in the problem, the temperature, then use directly at 4 degrees Celsius. That's why some books never mention anymore the 4 degrees Celsius, because that is the standard temperature in which we can obtain the standard value of the density of water. Okay? And the basis of all, 4 degrees Celsius. Okay? Like that. Sometimes also we'll not mention the viscosity. Okay? Like that. In the problem, here we are very lucky because there's at 4 degrees Celsius, but sometimes it will never be put, okay, because it's understood to be water already, standard, pure substance. Then you will be in trouble with the Reynolds number computation, whether it is laminar flow or turbulent flow. Okay? Sometimes you need to memorize basic standards, especially pure substances like water. Okay? The density of this, because the problem will sometimes no longer mention, especially the transport property, the density, the specific heat. The specific heat also at 4 degrees Celsius is just the same. 1 calorie over gram degrees Celsius. So it's not mentioned also here. Okay? But if the problem also asks for heat, you cannot solve because you think there's no specific mentioned because this is just water. Okay, then your problem is what is heat of the water flows in the pipe. Okay, then you can compute for the heat. And your problem is mass. Then there is mass also in the kinetic energy here in the equation later. Kinetic energy is also 1/2 mass times velocity squared. Oh, compute na mo siya because there is kinetic energy in point A and point B also, and there is mass. Then substitute that to the heat. So even though this problem doesn't require the heat, you can also compute for the heat being release. Okay, for this water flows through a horizontal pipe, something like that. Okay, but never mind that one because the thermodynamics is not mixed here. Okay, but there are occasions like that. Okay, that's the problem. Really, that's the problem. And mixing too much. Okay, like that. Okay, now in this equation, this is a momentum transfer, right? And this is obeying the principle of fluid flow and fluid mechanics. Okay, so momentum transfer is there. Momentum is equal to mass times velocity. That's why we have velocity from point A to point B. Okay, like that. Okay, so we need to use the Bernoulli equation. Okay, you will ask me again, oh, Mr. Sotero, why you will use the Bernoulli equation? We will use the Bernoulli equation because the other equations presented in momentum transfer are very complicated and complex. It undergoes integral calculus and differential calculus. And nobody wants to solve that in terms of integration and differentiation because it is very complex. Okay. If you want to, then solve it by other equations, but why you try to complicate yourself? And there is more easy or shortcut, or shall we say, easy to understand equation. It is practical to use, okay? So do not use that one. And most also with the calculation and computations are really linear, not always integration, differential, okay? Of course, you will use that also in the integral calculus examination or differential calculus examination. But in other cases, we should go back to the basic mathematics we will use, not this integration, differentiation, okay? Because this is not really practical, okay? You don't have to integrate and differentiate all the time in the actual practice, okay? In your work, in your career in the future. You always use the basic mathematics. I think you can use the algebra and a little bit of trigonometry and geometry because geometry deals with shapes and pipelines, a lot of shapes there, okay? And a lot of air compressors, something like blah, blah, blah. Okay, so we trigonometry and geometry, okay? But for the integration, it's used only in the design, okay? Engineering design, okay? Prior to have a complete structure of a plant. A plant meaning could it be a manufacturing plant? So before designing, okay, it's there that we use a little bit of integration, differentiation because of engineering. Okay, it cannot be denied. Engineering uses that in the engineering design stage. Okay, and prior to that, the conceptualization also. Okay, you can use also that one. Okay, but in here, no need to use that one. Okay, that's a reminder. If you're really intelligent enough, and then have a high IQ, then use it if you want to. Okay, because actually this linear equation also or basic mathematics can be used with those types of computation. Okay, but I'm just telling you, nobody wants to complicate a certain situation in which you have the practical equations to be used and more easy to understand. That's my point. Okay? Let's agree because you will expect me to do the integration, differentiation, okay? Because you are in front of me and telling that I am engineer, something like that, whatever. Okay. So if I am dealing with integration or integral calculus topic now, I will do that. If I was dealing also with differential calculus now, in my vlogging, I will do that also. Okay, but here, no need. Okay, like that. Mukhaan sa kong donut ha. Charot! Before proceeding the solution. Charot! Okay? This is donut, right? There is also a diameter. Wow. The inner diameter and the outer diameter of this donut. Okay? So we can compute for the cross-sectional area of this donut. Okay? So applicable, right? In an actual situation, if somebody will say, what is the surface area of the donut you eat now? Oh, I can solve because there's a diameter. Charot. Okay? So that was I'm telling you. So algebra only, trigonometry, geometry, because the shape is circle, right, of this donut. So I can compute for the surface area, the circumference, ganon. Okay? Look at this na lang siya. While inom ko kape. Okay. Bernoulli Theorem. Sa ganitong Bernoulli Theorem, go back to theory and concept. Bernoulli Theorem, sorry. The velocity increases, okay? And then the pressure will be decreased. Okay. The area is decreased, okay? The volume will increase. Okay, since there's no issue in elevation here, so don't think about that. If there is an elevation of a pipe, let's say, okay, then if elevation goes up, okay, the pressure will become lesser. So for example, 6th floor, okay, 6th floor, so you are in the 1st floor, okay? In the 1st floor, you have a very high pressure. At a lower elevation man siya, the pressure is high. So as you go on the top, the pressure will become low. Okay? Top of the building, 6th floor or rooftop. So the pressure there is low compared to the 1st level and in the ground level. So the height or the elevation is inversely proportional to the pressure. Okay? So let's think this 3 concepts. Sa ganito, velocity increases, okay, the pressure decreases. Area increases, okay, the volume decreases. Elevation increases, the pressure decreases. So inversely proportional with each other, something like that. Okay, so in that way, we can tell that after the solution, we get the answer, if we are wrong or not. Okay, because from point E, from point B, what is the velocity? For example, here, what is the velocity of water at point B? Something like that. So we need to know that it will increase back, ganun siya. So it will increase, okay? We don't know yet, but by the theory, okay, if the area is high, then the velocity is low, something like that, okay? Okay, correct me if I'm wrong. Okay, if the velocity is fast or is high, then the pressure will decrease. I will just write ha. Okay, mamaya na itong basis good. Okay? Diba? Sige. Okay, this is our concept. So if the velocity will becoming high, we're using U here, right? Not letter D. Becoming high, the pressure will decrease. This one. So that after answer, we can conclude that we are correct. Okay? Velocity goes high, pressure decrease. If the area, for example lang, will goes down, the volume will high. Or the velocity, sorry. No, I'm confused because of the letter. So let's agree that the V here is actually the velocity, not the volume. That's why I told you, keep on telling you this, guys. Okay? So I will use U na lang siya for velocity. Masipyat ko. Okay? So just because of the letter used. So for the velocity, U na lang siya ha, not because we have also volume man. Okay? So if the area will goes down, the velocity will goes high. Okay, if the elevation will goes high, elevation or height or vertical distance, for example, for a building like that, infrastructure, a school, whatever, okay, then if it continuously having so many floors or levels, then it will decreases your pressure. So elevation, it will increases. Okay, elevation siya ha. E, okay? And your pressure will decreases. Okay. So, at a higher elevation, your pressure is low. So the pressure is very high at a low level, something like that. Okay, something like that. This is also the principle of the airplane, huh? Okay, airplane. So the airplane will go up because of the pressure difference. Okay, so for example, you're traveling in a plane, so it will start normally with a low velocity initially, low velocity like that. At developing a low velocity, the pressure is high in this principle, right? Velocity is inversely proportional with the pressure. So if the velocity is low, slow, like this, the airplane, this example, you're going to another country, okay, like that. Me, I'm going to Philippines, something like that. Then the plane, I have the initial velocity. The pilot will give the initial velocity very low at first. And the pressure initially is high because inversely proportional. And then later on, the velocity will increase too much. It will become high velocity. And then the pressure will be becoming high. And then if the pressure becoming low, and the pressure becoming low, so the pressure high from the ground subtract to the low pressure at the top, then it will rise the airplane to the sky. Okay, that's the purpose of why airplane moving to the higher level, just because of the lift, L-I-F-T. Lift is the pressure difference, okay, like that. High pressure minus low pressure. Okay, high pressure driven by a lower velocity minus lower pressure driven by a high velocity. Because in the going up, velocity will be high. You need to put more velocity so that the airplane will go high. Something like that. Okay, so that's vertical distance covered from the ground. That is what we call a lift. It will be lifted up, something like the airplane. That's the principle of airplane. Okay, so that principle is applicable also in this momentum transfer. Okay, like that. So there's a momentum. Okay, why? There's a mass of the airplane and there's also the velocity of airplane. Okay, though the mass of airplane will never change, but the velocity changes. Okay, that's still under momentum transfer. Okay, so we should not forget this one really. Okay, okay. So in here, our area is 4 and it reduced. So what will happen for the velocity? It will goes high. Right? So expected na siya nga ang imong velocity will goes high. Okay? Like this. Okay, so mo na itong ipangita. Sorry, mo na itong ipangita ha. Okay? Velocity siya. Okay, so good na ta. Charot. Okay, so in here, we need to calculate first the Reynolds number to determine whether this is a laminar flow or not or turbulent flow, or is in the transition stage between 2100 to 4000. Because Bernoulli Theorem is applicable only to laminar flow or steady state flow, okay, following the law of conservation of energy, okay, and then it is understood to be that the mass flow rate, point A is equal to the mass flow rate B, something like that. And having this concept also, the relationship between pressure, velocity, area, and elevation, okay, like that. So it is also undergoing the concept of envisaged region, okay, like that. Then it's not really focusing on the shear stress, like that, or the momentum flux, it's negligible, something like that. So we need to, that's our the criteria. And limitation also applicable only mostly to the fluid or liquid. Okay, it's very clear. And then there's no issue with time here. Okay, take note. There's no issue of time here because the velocity is not dependent on time here. That's why the problem also it doesn't mention the time. There's no rate, blah, 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 chuba, chucho here. Okay? Because time is not really a concern with this particular laminar flow. Okay? So if there is a time, so you will also, think, this is a physics problem. Motion, ganon. So because it's there in the physics that time is always involved. especially the laws of Isaac Newton, the three laws of motion. So the velocity, the acceleration due to gravity, something like that. There are always seconds and times here, there, okay? Here, it's used only but to substitute, not for the concept, okay? Because we have also used this gravity later, okay? Used only to incorporate on the equation, but not in the concept here in the problem. That's what I mean, okay? Okay, magsugod na ta. Char. Okay. So we start with the energy form so that we can really understand, right? So we keep on solving and we did not understand that we defeat our purpose. Okay, like that. So start with energy form. Okay, energy form. So ganun pala siya, class, ha? If transport phenomena, momentum transfer, mass transfer, and heat transfer, this always follows the law of conservation of energy. Okay? And we are referring always to the molecular structure of the particular fluids, liquids, or gas that will pass through different media. Media meaning it could be a pipeline, a process vessel, a tank, something like a storage vessel, or whatever. Uh, shall we say a cyclone, heat exchangers, like that, a chemical reactor, whatever. So that's what we are referring to. Okay, energy form. So energy form states that pressure over density plus kinetic energy. Okay, I'll discuss you later. Kinetic energy u squared over 2. This is 1/2 u squared. U is velocity, as I said earlier, huh? Okay, plus, okay, this gravity times height. Okay, is equals to 0. Okay, this is the equation of energy. This one. Energy form. This is existing in our planet Earth. Every movements of living creatures or any artificial, machines, equipments, machineries made by human being follow always this energy form. Everything, okay? We do exercise, okay? We do our work. We follow the energy form equation, okay? And just now right? Even though I am sitting here, I'm following this equation because I have the potential energy while sitting and doing my live streaming. Okay? I have the mass. Okay? I have, though my velocity is 0, but I have the mass. Okay? And I have also the height of the chair between the ground. That's our elevation, something like that. Okay? This is the vertical height. Okay, so my hands also are moving. So, okay, my mouth is speaking. So there's a kinetic energy. There's a motion of my fingers, my hands, my eyes, my body are moving. So there's a kinetic energy already. So even though you will not move, you will just walk. So you have the energy form in your kitchen. Okay, you cook. Okay, you play, you dance, you sing. Okay, you're praying. Everything you do follow this equation, energy form. Because wherever you are, there's always pressure. That is atmospheric pressure. Okay, so pressure will be included here. That's why there's pressure, right? Okay, like that. Okay. So that is energy form. So we will say this one that this is kinetic energy plus potential energy plus the pressure energy. Okay. This first term here is the pressure energy, kinetic energy, the second term. Here is the potential energy. Okay. Now here in the Bernoulli theorem, principle, equation, marami kasi siyang terms, Bernoulli principle, Bernoulli theorem, equation, like that formula. Okay, we are focusing on the pressure form. Okay. not on the energy, because energy are too much general. And our problem also are dealing with pressures here. Okay? So, pressure form. Okay? Pressure form. So, first we'll start to the static pressure. Me sitting in front of you, I have the static pressure. So, static pressure, okay? Or stationary, like that. Static pressure. Okay, when I stand, I have the dynamic pressure. Ganon. Plus dynamic pressure. Because there's motion and movement when I stand. There's a vertical distance or height covered. Okay, so dynamic pressure. So this is explanation with actual demonstration. So as long as we can have that demonstration, then we can demonstrate that to you now. What is available only in inside my room. Okay. And we have the head pressure. What is the head pressure? This is mainly for the height. Okay, head pressure. For example, if I squat and then I stand like that and I go to the building, I can compute my height, vertical height. Then if there is density, then we can solve for the head pressure. Because head pressure class is density times height. Okay? So now since this is a pressure form, it's about time to discuss a lot of pressures in our planet Earth. Okay, I will discuss basic pressures so that we can understand really, especially to those persons who would like to become engineers in the future, students who will become engineers in the future, then please listen to me. There's a lot of pressures in our planet Earth. So I'll be able to discuss first the absolute pressure. Okay, so when it is an absolute zero, the pressure is zero. That what it means from the absolute zero. Now, if the problem in science will stay at an absolute zero, blah, 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 you will take immediately that the pressure is zero in the problem. Okay, so problems like that. At an absolute zero, the volume of this gas will go to this. Blah. What is the temperature? This blah blah blah, and then pressure is always zero na siya with the concept ay kalibo because pressure is not there. Okay, so pressure is zero at an absolute zero. Okay, now pressure above absolute zero, of course, that is called absolute pressure. Okay, so the definition is a pressure that is above absolute zero is an absolute pressure. Okay? Like that. Now, the absolute pressure is composed also with gauge pressure and the vacuum pressure. Okay? Wow. So the gauge pressure is this pressure that we have in the machine, our equipment to measure. Okay, there's a pressure gauge, especially in the pipeline. Okay, different power plants, chemical plants, or any manufacturing plants, there are a lot of processes there, and they will incorporate the pressure gauges. Okay, like that, because we need to calculate also the pressure drop of those fluid, so that we can really calculate the velocity, the volumetric flow rate, the mass flow rate of the substances or any fluids that will go inside the pipeline, right, to produce our products. And that is operating parameters. Okay, then we have the gauge pressure for that. Now, plus the vacuum pressure on the bottom part and the upper part is the gauge pressure. Okay, I will show you. Okay, and we have the atmospheric pressure. Atmospheric pressure above sea level. Okay, that is the definition. Atmospheric pressure is a pressure above sea level. Okay? So, atmospheric pressure is the pressure above sea level. Something like that. Okay? Like that. And the pressure is beyond the atmosphere. The gauge pressure is beyond the atmospheric pressure. It's above. Okay? And it's the bottom is the vacuum pressure. It's the pressure below atmospheric pressure. So that is vacuum pressure. Okay, so absolute pressure is equals to gauge pressure plus vacuum pressure. So if you can see in the problem, this is PSIA. That means that's an absolute. A stands for absolute there. PSIA in the problem. So be careful. We'll never substitute the PSIG because PSIG is a gauge pressure. So that's also some students, including me before, I will be confused because I will directly substitute that there. Actually, it's not yet that pressure that the problem requires. Okay, because there's a PSIG. Okay, pounds per square inch gauge pressure. Okay, that is the pressure above atmospheric pressure. Okay, PSIG and PSIA. That is a pressure above absolute zero. Okay, like that. So if there's no such identification, then that is the standard really. Okay, because sometimes it will not also specify. Okay, but if it is specified, it is sure that there's a purpose for that. Okay, you need to go to the basic mathematics. Okay, for that. Absolute pressure is equals to PSIG plus vacuum pressure. Then do the mathematics. If the PSIG is given and you can determine the atmospheric pressure, o ganun siya. Okay, because usually what is given is the atmospheric pressure. Okay, like that. Okay, atmospheric pressure, as you can remember, at standard temperature and pressure, right? At standard temperature and pressure. Okay, so it's gonna be like that. So 180 aim siya parati, something like that. Okay, 1 atmosphere. Okay, 180 m is the atmospheric pressure. It is equivalent to 760 mmHg. Okay, this is the point that the head pressure will be used because of the word millimeter. 760 mmHg. So there's mm there. Then you can solve for the height. Okay, this is the only special unit and pressure that has the distance. Okay, mm, 760 mmHg like that. Because the others are having the surface area. And then equivalent also, 1 atmosphere equivalent to 14.7 psi, pound per square inch. Okay, 1 atmosphere equal to 1.013 bar. Actually, bar and atmosphere closely related to each other, very close to the value. 1 atmosphere is equal to 1.013 bar. That's why some books, based on my research before, as far as I could remember, charot, okay, that is very close. And some books using 180 m is just equal to 1 bar. Okay, but actually the 0.013 is just very small. Okay, even though you will compute that in the problems, it will not change a lot. It will change in the second decimal places, point something something, so it will not matter for your answer also. But to be precise and accurate, it's better to use the 1.013 bar. It's equals to 1 atmosphere. Now, in terms of Pascal also, we can determine that because it's related to force, okay? Remember, force, the unit is Newton, right? So it's there that you'll be able to use the Pascal. Okay, Pascal is Newton per square meter. Okay, so you can get the force by having the pressure. Okay, something like that. So 101,325 Pascal. Oh my gosh, it's equals to 1 atmosphere. So just try to think that only Pascal have a higher value. When you memorize something, just think that Pascal has a very high value. So automatic, your brain cells will detect that it's 101,325 because there's no other. And then if you try to recall the kilopascal, they convert that conversion factor so that will be 101.325 kilopascal. So 101.325 kilopascal is equals to 1 atmosphere. Now, these pressures issues are very useful in process industries, especially in different chemical and physical processes throughout the plant, because this is a parameter, just like the temperature, okay, the velocity, okay, the mass flow rate, the density, the concentration, okay, this matters a lot, okay, for the, designing an equipment, a machine, or in a process, okay, something like that. So, itaas ang atong istorya because we are dealing with pressures. Okay? So, if I will ask you, what is pressure? So that is a force applied to a certain object or a given object to a particular area, something like that. Okay? So, because the definition of pressure is equal to force over area. Or it could be, it is a force applied in perpendicular to the surface area. Because a pressure is always applied in a particular area. That's common sense. You always apply in the area. Could it be a square, rectangular area, trapezoid, rhombus, cone, okay, like that, rectangle, cylindrical, okay, round, circle. Those are the shapes, right? Everything in this world have shapes. My room is a square room or rectangle room, so there's an area. Okay, so I can apply now the pressure here inside my room. Though I did not know the pressure, but I can compute also. Okay, if I have the gauge, pressure gauge, or the device to do it. Okay, something like that. So that's pressure all about. Okay. Don't forget that the pressure is constant force over area. That is very, very basic in physics and chemistry. Okay, going back to the pressure form. Okay, our static pressure will just equal to P. So Sotero, why P? Okay. Now, it becomes P because the energy form will be multiplied all with density. Okay. As shown, density is constant throughout the process. Okay. Density, so it will become now P plus density U2 over 2 plus density gravity H is equals to 0. Guys, in derivation of equation formulas, it's in here that our stat knowledge works. Okay? We are going to school, elementary, secondary, primary, tertiary, like that. Those education helps a lot because we memorize basic concepts. Okay? And knowledge in science. And those basic concepts, you will never forget that for the rest of your life when you grow old. Okay, like that. Not to be arrogant and not to be boastful. Until now, I can remember the basic formulas. Okay, I can still remember the Pythagorean theorem. I could still remember also the quadratic equation, even though I am old. I took my college days when I was in 25 years ago. But because you memorize it and you understand it, it will stuck to your brain. It will retain to your brain cells, even if you are old. Okay? It's just because I love science, because my course is chemical engineering. That's why I think, because most or other people also don't remember the formula. Okay? It depends on the person interests. Okay? Especially if their career is related to science, like that. Okay? So just like me, my career is related also to science. Okay, so that's why. Okay, so please remember that pressure is equals to force over area. Okay, all the time. And pressure is also equal to density times the height or the elevation. Okay, so equate that one, you can formulate another formula. Okay, blah, blah, blah. Okay, and then since force is a quantity in the formula of pressure, then we have also the acceleration due to gravity or the second law of Newton. Force is equals to mass times acceleration. It's in there that you will be able to equate, okay, the formula of force in the second law of Newton and then to this basic pressure is equals to force over area. Then bingo, you can create another formula also by connecting the dots. Okay? Like this, just like a politics topic, you will connect the dots, the history of those politicians, why it goes like that. There's a corruption because of the previous administration. It's just like that. We need to connect the dots in science and in mathematics. Okay, simply like that. Okay, and we will use that here also, even though the topic is a little bit higher. Okay, this is higher because this is under unit operations, transport phenomena. Okay, so there's a lot of prerequisites for this before taking up the subject.
general chemistry, quali, quanti, blah, 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 physical chemistry, okay, like that, chemical calculations. So prerequisites meaning you cannot take this subject without passing those subjects, okay, like that. And this is really a sort of higher subject or major subject in chemical engineering, okay? Like that. I will be trying to explain to you the most basic lang siya, ha? Because this is for everybody man siya, so that we can understand. Anyway, this can be applicable in our environment also, okay? As I told you a while ago, okay? Like that. So if you multiply the density with the energy form, we can obtain this equation: pressure plus density, velocity squared over 2 plus density times gravity times h. Okay, let's take a look closely. Pressure, this is a static pressure derived from the energy form. And the second term, this one, density u squared over 2 is the dynamic pressure. Okay, we need to say there's movement, there's motion because it's derived from kinetic energy. Okay, plus density times gravity times height. And then this is the potential energy. Okay, it's an energy at rest. Okay, that's potential. So not yet moving. Okay, something like that. So this is gravity times density times height. Now, remember also that in the physics, very important value of acceleration due to the gravity. This is the gravity what we are referring to. So the value is 9.81 meter per second square. Okay? I'm talking too fast. That inject also this into your brain cells. Now, if you're a student right now, memorize. Okay, so that when you reach 30 years old, 40 years old, 50 years old, you will never forget that there is an acceleration due to gravity, which is 9.81 meter per second squared, equal to 32.2, okay, like that, feet per second squared. Okay, 32.2 feet per second squared is for the SI in English unit, and then 9.81 is meter per second squared is for the metric system. Okay, memorize that one. Okay, if you want to become, an engineer in the future, something like that. Okay. So, or if your course are really related to science, because those, money courses, finances, banking and finance, psychology, College of Arts and Sciences, they are not interested also with these numbers. That's why. So I'm telling you, if you want to become an engineer or related science courses, then memorize, okay, so that you will not be lost, okay, especially in a chemical engineering board examination or in an engineering examination conducted by the Philippine Regulation Commission. Okay, so memorize, okay, the basic concepts. Don't have time to, derive in the actual examination. Just understand how it arrived like that. So even though they will try to mix that up, then you can really answer. Okay, because there is also, based on my personal confession, really, in the examination, you have to formulate your own problem, really. Okay, because sometimes you cannot understand, oh my gosh, too much mixing. Okay, too much in one problem, too much mixing, all the topics there. Okay, oh my gosh, what is the formula I will be able to use this now? It's really confusing, really, especially the heat transfer. Okay, and sometimes it will involve also thermodynamics, and then it will connect to the transport phenomena. Okay, something like that. Okay, so this is the pressure form. Going back. Okay. So we will use this pressure form now for the Bernoulli Theorem. So this is where we concentrate and focus with in the fluid flow or fluid dynamics. Okay, like that. So examine closely what are those quantities that will be always be using and inject in your brain cells. Okay, like that. So the pressure, the density, the velocity, the gravity, and try to connect other quantities also. Could it be a scalar quantities, vector quantities, and a tensor quantities? I discussed it already in the previous vlogs, right? Okay, no need to explain further. Okay, now let's solve this now. Too much with presenting with equation. Okay, like that. So isolve na nato siya ha. Okay, now. Again, we will not be using the Navier-Stokes equation. Okay, still for fluid flow, fluid dynamics, and for we will not use also the Euler equation either. But we will use the Bernoulli theorem because of the three or how many equations are that in momentum transfer. This is the most understandable, basic, and easy to use equation of all because doesn't require too much integration and differentiation. Doesn't involve that much, or it doesn't really involve this integral calculus and differential calculus. It doesn't mean I avoided that because I'm just telling it is really complex to do that. Okay, like that. Because also in integral, we can solve that by ordinary algebra. We can still get the same answer man siya. Okay, but we are using the solution in terms of differentiation, integration. But if you use also the basic algebra, basic mathematics, you can still use that equation, and then you can produce the same answer man siya. Okay, so why complicate yourself? And there is easy equations to be used. Okay, like that. Nobody wants to complicate certain situations. Okay, like that. So number one. Okay. Basing in our drawing, ganon. Now, and then, okay, nahuman naman tayo sa concepts and given. So, let's go to the required. So, the required are those we need to answer in the problem. So, the first required is, okay, at point B, okay, what is the velocity? So, meaning V of UB. Okay, UB. So, it depends on you. If you use VB small letter, then no problem. Okay. And then, calculate the pressure at point B. So, PB. Okay. Point B man siya. But you can also use point 1, point 2. It depends on you, right? Whatever letter you designate for that. Okay. Number 3, calculate the pressure. Number 3, calculate the Reynolds number. Shwada. Number 4, determine the total volume feed in the pipe. Charot. Okay? So this is the capital V. That's what I am telling you. Ang dami naman. Number 5, calculate the total length of the horizontal pipe. Total length. Length of the horizontal pipe. So LP na lang siya. Okay, liberal party, dilawan. Okay, like this. LP, length of the pipe. It's not liberal party, but length of the pipe. Okay. Number 6, oh my goodness. Volume. Oh, enough na siya. 5 lang pala siya. These are the required we need to answer for. Okay. Now using the Bernoulli equation. So let's go to the pressure form. We copy only. We copy here. We use this basic equation to put in the Bernoulli equation. Okay. Pressure plus density U2 over 2 plus gravity density times H is equals to 0. Okay, now class, since this is obeying the continuity law or the law of conservation of the energy, so the mass flow rate of point A will be equal to the mass flow rate of point B. Okay? Because that is steady state flow man siya. Okay? If steady state flow, equate the output and the input. Okay, especially if there is no issue in the elevation level. This is only horizontal, okay? Unless this second pipe is going up, it's going down. So you can never do such thing as a steady state. I think so. Okay, this is not equal already, right? The elevation changes. Okay, like that. But still you have to follow the law of conservation of energy. Okay, but what I'm telling you, it would really matters. In this case, there's no elevation issue for this. This is horizontal pipe entire process. Okay, let's assume this, that this is a fixed horizontal pipeline. Okay, like that. So, ganun siya. So, point A is equals to point B. Ganun siya. Point A is equal to point B. So, gather all the A and put that here. Okay? So, PA, okay, plus density A plus UA raised to the power 2, 2 plus density A, gravity A, HA for A. Because I tell you A is supposed to be, all A will be here. Look at the, subscript, all are A equal to the B's, okay? So pressure B, density B, velocity B squared 2 plus density B, gravity B, okay, and HAB. So equal na siya because of the continuity law, the law of conservation of energy. Okay, we use this. Okay, now in this situation, the elevation is not an issue. It's constant. So it's 0. We need to cancel this gravity thing here. The last term. Density A, GA, and HA, and density B, okay, GB and HB cancel because it's not an issue for the gravity. It's just the same. Okay, and there's no elevation. Okay, so 0. Rejected from the equation. Ganon. So what will left is these quantities. Okay, rearrange the equation. Okay, something like that. So I could transpose all the terms in the right side to the left. So like this. Okay, so PA, all similar quantity, put that together. Okay, and then transpose. What I mean with transpose, you have to carry the plus and minus sign after you transposed. Okay, if you transpose this from positive, it will become negative in going to the right, and vice versa. If you transpose this item positive, it will become negative if you transpose that to the left. Gather and combine all have the same similar quantities. Okay, to simplify the equation. Okay, something like it's a PA. So all pressure, there's also pressure in the right side. So PA minus PB. Okay, ganon. So PA minus PB, since the same quantity man siya pressure, so put a bracket to make sure hindi siya mubuwag. Charot. Okay, PA minus PB. Okay, like that. Since all the time you will remain one term only to solve for the desired quantity. So equal directly. Okay, equal directly to the PB. Okay. Oh no, PB is transported already. So it become density na lang siya. So density B, be careful ha. When you do this individually, be careful because something wrong, your answer will be wrong also. Okay. Over 2, ganon. Okay. Then, density B, okay. Velocity B raised to the power 2 over 2. Then, this one will transpose here, negative na siya. So, negative density A, UA raised to the power 2 divided by 2. Okay. So, this is our first equation. Okay. So is this enough, this equation, to solve for UB? Yes, it is. But try to look at the certain other quantity if it's okay already. So we have the density of water, 1,000 kilogram per cubic meter. We have the gravity, right? No, gravity is already canceled. Sorry. Okay. So like that. I love gravity. That's why 9.81. Okay. So here pressure already identified, but we don't have pressure in the second point. Okay, so that's a problem. There are still two quantities need to be solved. So it is understood we need other equation. In mathematics, if there are two quantities to be solved are required, we need also two equations to satisfy what we are asking. Okay, again, in mathematics or science problem, if there are two quantities that are being asked, we need also two equations to satisfy what is being asked on the particular problem. It's not enough only one, or else you will be confused because you don't have yet the pressure in the B point, and you don't have also the velocity in the B point. Now that is the time that I come to think with another formula to make it two. We have the continuity equation, which is the mass flow rate. Okay, mass flow rate point A is equal to mass flow rate point B. Ganon. Okay, so mass flow rate, I should denote that as McDonald symbol. Okay, like this. Small letter M, McDonald symbol for mass flow rate. Wow, ang sarap niyan. Oh my gosh! Oh, there's a conduction process. Wow. Fourier's law of conduction in my coffee. Heat transfer, okay, from hot to cold. See, everyday life have heat transfer. Okay, because this is very hot at first and it becomes cold, so it undergoes the heat transfer or the heat transport. Meaning to say, from high temperature to lower temperature. So apply, automatic na siya na apply ang heat transfer, even though I did not yet have the problems for heat transfer. See, everyday life talaga have transport phenomena. Okay, so we will die without transport phenomena. Okay, very clear how we will die without transport phenomena. Why? Because the blood have momentum transfer also, velocity, desired velocity, okay, to go to the particular organ, to supply for the oxygen, for the nutrients, different cells and tissues in our main organs, so that we keep alive. There is a momentum transfer. There's also a heat transfer there because we used fatty acids, okay? It's released from the liver to be used as a fuel, and heat will be there, okay, to derive and to produce our metabolic cycle, to drive our good metabolism and to support body muscles function. Okay, so heat transfer, momentum transfer is already there. So the last one na lang, mass transfer. Yes, it's needed also because we have a lot of concentrations in our food that we eat every day. Okay, so if there are concentrations, molecular concentrations that we take in every day, such as the food, rice, protein, meat, then bingo, mass transfer or concentration changes always inside our body. So actually, this is really useful, this topic. The only thing we don't understand that we don't really know what is the applicability that in our body and into our planet Earth. Okay, that's the magic and wonders of science. That's why I love science so much. Okay, like that. Okay, going back. And even mathematics is only part of science. Okay, because those scientists before doing the scientific research, the formulas and equations are later. Okay, they still do the gathering of data, experiments, analysis, hypothesis like this before they come up an equation. Meaning to say, mathematics is only secondary, science still ahead of it. Okay, like that. So meaning to say, mathematics is just a part of science if you try to dig it up. Okay, very clear. Okay, like that. So that's why I love science very much. Okay, so where we are now, okay, Mach-Duke symbol represents mass flow rate. So mass flow rate of A is equals to mass flow rate of B. Now, we think again for our basic equation for mass flow rate. Again, thinking rate. Oh my gosh. Rate, there is a denominator time. You remember that one, right? But in here, take note. This is special. Charot. Ano man to eh? Wala na ko space. Okay. Grabe, one problem. It takes me so long, right? Because they did it in, in a detailed fashion, in a detailed manner. Wow. Okay. Mass flow rate A. Okay. Your identification is really mass because this is mass flow rate. It is not volumetric flow rate, though they are related with each other, but here mass flow rate. Okay, like that. So if we think about mass flow rate, so density must always be involved there. Okay, we come to think for quantities that this are connected or this is connected. So density is equals to mass over volume. Okay, bingo, because there's a mass there. So substitute that there already. Okay. So, density. Ganon, ganon. So, density na, mayroon na siya. Density A. Now, you come to think, density, the unit is kilogram per cubic meter in this problem. Because it depends on the problem man siya. So, kilogram per cubic meter. Now, come to think for another quantity that involves matter. Okay? That's involved matter, and at the same time, it involves also time. Because this is rate man siya. Okay? Rate gani siya, automatic time will be there in the denominator. Okay, so think of a quantity that involves a time. Okay? So think a lot, right? So, since this is transport phenomena, so velocity, meter per second. So, you have to put that there, times the velocity. Okay? This is in case unuseful when you forgot the formula of mass flow rate. Okay? So if you memorize, then no problem. But if you forgot, then try to manage the cancelling effect. It will goes to your unit and bingo. That is the formula of what you are trying to find out. Okay? So velocity. Okay? Velocity A. So, meter per second. Okay, satisfy na siya because we have second in the denominator, so rate na siya. Mas for it. So, still, we need to have problem for this because if we try to cancel this one, it's not enough. Okay, let's say that we are enough for this. We try to cancel meter, and then it's kilogram, meter squared per second. But kilogram, meter squared is not mass flow rate. So we need another more quantity so that it will become a kilogram only per second because that is mass. So kilogram. So come to think with another quantity also for that. Okay. So you come to think. So area will be there because area is being specified in the problem. Then if you try to cancel that one, meter squared, what will left is the kilogram per second, which is the mass flow rate. Okay? Ganon siya. Sometimes ganon siya after your memory fails. Okay? You should try to multiply certain quantities, then cancel it out, and the unit will satisfy to that quantity you are asking for. Then that is the correct formula. Okay? But memorize first, okay? Understand and memorize first. What I'm trying to say is that you forget somewhere along the way. Okay? Like that. So area A. So kailangan siya m squared. So cancel. Okay, like that. So kilograms, seconds ang mahabilin. Okay. Take note, kilogram per second is mass. Okay, in numerator. Flow rate. Rate, time in the denominator. Flow, because it is a movement. Okay, or in motion. The water is in motion and in movement while it is having the second. Okay, like that, or for that particular flow. Okay, so since we have now kilogram per second satisfying the mass flow rate A, equate to mass flow rate B. Okay, like that. B also is the same thing. Okay, so we have density B, UB, velocity B, and the area B. Okay, ganon. Okay, so equate that to. Equate meaning you have to put that in equilibrium stage or in a steady state. Okay, so density A, UA, okay, and A A is equal to density B, U, B, A, B, equation number 2. So we have now two equations to satisfy what are being asked on the problem, something like that, blah, 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 so and so. Then other required are being support only, support questions. But our main equations are this. Okay, now, substitute na ta because we have now two equations naman siya talaga. Okay? Oh, ganon. Okay, density A. The density of water at 4 degrees Celsius is 1,000 kilogram per cubic meter. Though it was not mentioned in the problem, then by common sense standard, it is 1,000 kilogram cubic per meter. If it is a water, okay, and not specifying at a certain temperature, that's understood to be like that. But if it is an other inorganic liquids, then go to the reference appendix table section in the chemistry books, physics books, or it would be better refer to the Perry's Chemical Engineer's Handbook. Okay, I think it is a table blah blah blah. Okay, table 2 does blah blah blah. Then go there. Okay, because you will be afraid also because there's no data at all. Then use that. Okay, so that you can have the data. Okay, like that. That's why I think in all engineering board examination, it's open book nowadays. I think so. Open book because of that issue. It will take time for the students to, scan and and no more time to review the questions. Really, it will take time really. That's why we labeled the section to section so you can easily get the values of those physical data or transport properties data or chemical data, right? Okay? So, substitute. Okay, density A, 1,000. Ganon. Okay, 1,000. Di lang ko mag-put a unit because it's very tasky. Let's try to do it later. Okay, velocity A, mayroon man siya, gihatag man siya diri sa illustration. Okay, which is 5 meter per second. Okay, substitute that here. Okay? 5. Be careful also in substituting, because if it is reversed, that will become problem. And admittedly, that is my problem also. Most of the time, I mix like this. Okay? I have to be honest. Okay, sometimes I mixed up, and then though I know the equations, I know the formulas, but due to very eager to solve the problem, then there's a tendency to be like that. I'm telling you to be careful before you substitute. Okay, so like this. No, wag tanjun ang drawing. Asa naman yung drawing? Dire, okay. 5 meter per second. Substitute. Okay. Ang area niya, okay, gihatag. Okay, 4 square meter in the inlet siya. Kasi 4 square meter force siya. Okay. And then, density B is also 1,000 because there's no changes in density. It is only one component is there, one substance, water. So this is still 1,000. Okay. So velocity B is what is being asked. Okay. Here. And then this velocity will come here outside. Okay. So it is expected to be higher, right? Your velocity must be higher. Okay? Like that. Okay, so we have UB na siya. Velocity at point B. Computer na nato siya. So, okay? Then try to figure out 1,000 and 1,000 will be cancelled man siya, right? Same siya, same quantity. O, cancelled na siya. Okay? Okay, so like this. Okay. Ganun lang siya. And then 2. Okay, UB will be equal. I-compute ko nun ninyo. Okay? Because this still AB area 2, compute ninyo pila na siya, and that will be our velocity at point B. So our velocity at point B will be, tempasa ha, automatic 10 siya by just looking. No need to get the calculator, just look it out, and then the answer will be 10 meter per second. So it's increasing. It's increasing, right? Because the pressure decreases. Something like that. How do we know? Yes, by theory muna. Hindi pa natin nakukuha. We did not yet get the pressure sa ano din. Because of theory, I depend on theory. Okay? But it's 10 meter per second na the velocity. Okay? Labeled now here in your drawing. Okay? So, velocity B is 10 meter per second. O, na-answer na nato ang kapila to siyang gipangayo. Number 1, velocity UB, na-answer na siya. That is 10 meter per second. Ganon. Okay. Pressure B. So, substitute this velocity B in the first equation because it involves pressure there. It's our equation 1. Okay, it's here. Okay, it's here. Okay, substitute that there. Okay, 1 by 1. Okay. Dili na lang ako ikarga ang equation. I'll just substitute directly. Okay. So, PA, pressure A in this situation, okay, is, okay, what is being mentioned here? So, wala to mabutang ang pressure. Okay. Wala to mabutang but it can be traced. No problem. Okay. Ganun man siya talaga. We need to trace out if something missing. That's part of the analysis, right? In the solution. So PA is equals to 300,000. Go back to the problem. That's the basic technique. Just like this, only not writing, okay? So that is Pascal. Okay. So 300,000 Pascal ang PA siya. Okay? So don't be afraid that it's very high, huh? Oh my gosh, it is 300,000. Okay? Pascal. So we have initial pressure at point A which is 300,000 Pascal. So PA na siya. Substitute for the first equation here because we already get also the velocity B. Okay? Like that. So substitute na siya, no? Okay. PA. We should use this equation 1, ha? Okay. PA, 300,000. Okay. Minus PB is equals to density B, 1,000. UB, nakuha na siya 10 raised to the power 2 divided by 2 minus density A is just the same, 1,000. Okay, UA, in our drawing, we have a velocity that's coming in, which is 5 meter per second. Here. Substitute. Okay. So, 5. Okay. Over 2, right? Raised to the power 2 divided by 2. Ganun na siya. So, klaro na kayo na ang nabilin is only PB, which is the pressure at point B. We can calculate and compute the pressure at point B with this numbers inserted. So, calculate PB na siya, pressure at point B. Okay. Pressure at point B is equals to, mathematics na lang na siya, simple mathematics. Okay? Like that. So, let's be patient. Ganun talaga siya. Okay? 25 divided by 2 times 1,000. 12,500 here. Then 100. Dali lang kayo kaya siya na naman siya yung numbers. It's equals to times 1,000. Okay? 50,000. Okay. Put that as a bracket. I put a bracket class because these are having the same quantities at first before you substitute values. Okay? And then you will try to transpose this 20,000 to the right, so it becomes negative. Huh? as I told you, everything you do the transposing, okay, it will change the sign, okay, minus 300,000, okay, then do the mathematics, basic mathematics na lang siya, okay, so 50,000 minus 12,500 is equal to minus 300,000, okay, so we have negative 262,500, but still there is also negative here, okay, here, so it will become positive, okay, look at the sign. Anyway, for the pressure, does it really matter the negative sign? Okay, unless it is a velocity. Negative meaning decreasing velocity. The pressure is not an issue to have negative because by theory, pressure don't have negative that much, right? If you remember, do you encounter negative pressure so far in your entire life? Negative pressure, usually. Di ba? Parang wala siya. So, even if nagkamali ka because you are not carrying the negative, you have to think most of the pressure are not negative. So, just answer the same with this. But in this mathematical formula, we can consider negative siya. Okay? Because sometimes you will forget also the sign, okay, to put. But in this manner, cancel, pressure B is equals to 262,500 Pascal siya. Okay? Because Pascal man sa dang A. Okay? So Pascal po ang imong unless there's a changes in it. So pressure B will be 262,500 Pascal. Take note, the pressure is reduced while the velocity increases. Okay, the water flow from 5 meters per second initially at point A, and then going to point B, the velocity is 10 meters per second. So velocity increases. Now, the pressure is in reverse. The pressure started from 300,000 Pascal in point A. Then, if it goes in the different diameter throughout the horizontal pipe, in point B, it became 262,500. So, the theory is really perfect to show and to prove that our answers are correct. Okay? Because of the theory and principles behind. So, our pressure at point B is equals to 262,500 Pascal. Oh, nasira na siya. 1, 2, already answered. So number 3, what is the Reynolds number? Actually, first na siya compute dapat, no? To determine the laminar or whether turbulent. It's okay. So, Reynolds number na ta. Char, ano eh? Grabe. Problem 1, it takes a long time because of the, Reynolds number. Okay, saan siya nga number? Number 3, no? Okay. Reynolds number. Actually, there are a lot of numbers, ha? Hindi lang kay Reynolds, na yung mga Schmidt number, Nusselt number, Sherwood number, okay? Like that. Stokes number, Euler number. So I don't encourage you to memorize that, but go to the most common, especially the Prandtl and the, Nusselt, Prandtl, and Schmidt, because those are heat transfer number, aside from the Reynolds number. Because I think most of the students, especially chemical engineering, best chemistry students, are memorizing the Reynolds number, of course, because we cannot compute. Okay, like that. This Reynolds number, along with the Prandtl number, Schmidt number, Sherwood number, kahit 4 lang siya, i-memorize lang niyo siya ang formula. Okay? Actually, it's in the handbook, but no more time talaga siya na hanap-hanapin mo pa siya, whatever. So sometimes it will goes out in the question. For example, blank is the, let us say, nakakalimot na si John sa mga stock knowledge. For example, Schmidt number. Charot, Schmidt number talaga. Really? Okay, this will be the mass diffusivity over the molecular diffusivity. Ganon. Okay? So, mass diffusivity meaning mass transfer, right? Do you remember that one? So, mass diffusivity over the mass diffusivity over the molecular diffusivity. Okay, something like that. So that is our schematic number. Okay, again, I will show schematic number. Lisod siya, no? Char! Lisod talaga. Okay. Like this. Mass diffusivity. Okay, then over the molecular diffusivity. Then ganon. Oh, never mind. Okay, because naglibog ko because, you know, I'm confused with these numbers. But I'm telling you, I don't encourage you to memorize, okay? But it's better to memorize, okay? Because sometimes it takes time also to scan the handbook or the books. Then if you know the formula for this, okay, then you can. The question asks, what is the schematic number? Then you don't have an idea. Then you have to scan the book. La, sige, sige. And there are a lot of pages for that. So it's if you memorize that one, then you can easily answer. But in this case, I forgot what's that. It's a very long time ago. Oh my gosh. I use the, you know, memorize the schematic, the frontal and the nasal, and then Reynolds number, of course, should be memorized. But this also should be memorized. But there's also equivalent formula for this, for Transpott phenomena. Okay? Like that. So, ako yung nanaon ni schematic number basta ni dito siya og mass transfer. Okay. When you deal siya og mass transfer, that means it involves, diffusion coefficient, right? Diffusion coefficient. Okay, so diffusion coefficient. So that means molecular diffusivity, right? If it is a mass transfer, molecular diffusivity. Okay, so since molecular diffusivity, so that means over the, oh my gosh, very difficult really, no? Over the kinematic viscosity, something like that. I'm not sure. That is for the schematic. But for the nacelle, okay, it's heat transfer as far as I can remember. Sure na ako na pag nacelle, heat transfer. The schematic number, mass transfer siya. Pero the formulas, I forgot lang siya talaga. Okay, what's in the numerator, what's in the denominator, but I think, kaka muna ha. Napagod yung brain cells. Okay? If it is a heat transfer, it involves the, so that is diffusivity, okay, over the, okay, momentum diffusivity over the thermal diffusivity. Okay, ganun pala siya. Okay, work na akong brain cells. Okay, okay, because, okay. So, Nusselt number is equal to the momentum diffusivity over the thermal diffusivity. Ganon. So, ang denominator dahil siya, magbase siya sa heat transfer. Okay? But ang numerator, magbase siya sa momentum. Because it's in the momentum that the viscosity are always expressed of. That's why we need to incorporate the momentum diffusivity in the numerator. Correct me if I'm wrong. That's what I understand. And then, for the schematic numbers, still momentum diffusivity in the numerator over the, so kinematic viscosity na siya. Okay, because kinematic siya for the, no, it's not kinematic, it is the diffusion coefficient or the mass diffusivity. Sorry ha. Okay, because our numerator is momentum siya, no? It's not, di man siya pwede na puro siya momentum transfer. Okay, so that's what I'm telling that I'm wrong. So momentum transfer over the specific momentum transport phenomena, what we are referring to. Since we know schematic number is referring to mass transfer, right? And this heat transfer is for NASA. For schematic is for the mass transfer. Then our denominator will be the diffusion coefficient or the mass diffusivity. Ganon. Okay, mass transfer man siya. Okay? Bakit mo kalibog sa? Okay? So never mind. So what I'm telling you, just memorize the basic. And I don't encourage you to memorize all the complicated. Okay? I think there's at least 10 Reynolds number, Nusselt number, Sherwood numbers, Kebelit number, like that. Okay? You memorize that also, ha? Basic. Chemical engineering students. Okay? Anyhow, it's in the handbook. Okay? But it's better lang talaga siya to save time. Okay? During examination. Okay? Because sometimes memory fail just like this, right? When memories fail. Okay? Grabe. Oo, nag-fail na siya eh. Okay. Reynolds number. Because I don't review that much in the theory, okay? I review more on the formulas and equations. Okay? That's why. So, Reynolds number, there's a basic formula I could remember, and some chupa-chucho, but there are also the length times the density times the velocity over the absolute viscosity or dynamic viscosity. Okay? Makalagot yun ang viscosity sa this is the absolute viscosity. This is not the kinematic viscosity, ha? Okay. Now, in the problem, again, as I told you, it's not mentioned whether it's a kinematic viscosity or absolute viscosity. Just use the, ano na lang siya, absolute viscosity, okay? So, mo ni siya. We have now the new denominator already. We have the length. The length really is our, our diameter. Okay? Changes in diameter lang siya from area 1 to area 2. Okay? Like that. Kung mo na siya i-refer. Okay? Asan mo itong drawing, oy? Okay. So, this is the area per square meter. So, area is equals to pi d squared over 4 because this is round in shape. Okay? So, this is cross-sectional area, something like that, pi d squared over 4. So, you need to account the area 1 and area 2 in this case in getting the Reynolds number because we are concerned with the diameter. Diameter at A and diameter at B because it changes in area. Okay? Like that. So, we need to compute for the area 1, pi, diameter 1 raised to the power 2 over 4, and area 2 also, pi, diameter 2 over 2 over 4. So, 2 means B, 1 means A. Okay? Substitute na lang siya dito. Okay? So, sa first point A, for meter man siya, our area. Okay? So, is equals to 4. And then sa area 2, our area 2 will be 2 siya. Okay. So, ganon. So, ganon siya ha. Okay. Area 1 is equal to pi d squared over 4. Area 2 pi d squared over 4. The same lang siya. Mag-matter siya sa points. So, 4 square meter ang area 1. 2 ang area 2. Okay? Solve for the value of the diameter of each. Okay? It's very easy na talaga siya. Kaya usara may required. So, D1 is equals to, so, algebra. 16. So, D1, oh my goodness. Okay? Divided by pi. Pi daw. So, 16. So, if this is raised to the power 2, then the square root. Right? Square root siya. Okay? This is for A. Pi d squared over 4. Do the mathematical operations lang siya. Basic. And then square root of area 1. And it will become the square root of ano na siya, D by solving D. Okay? So DA or D1, just put that DA to be specific and consistent. Okay? So, calculator. Okay? Pi. Naman tayo pi diri, di ba? So, pi is 3.1416, ha? Based on our memory, right? So, 16 divided by 3.1416 equals to square root. Ay, ganon. So, the diameter is 2.25 meter sa A. Sa area A. Sa area 2, okay, same siya, but you have to solve for the D2 or DB. Okay? Same thing lang siya. Okay? But the diameter is not 2 already. It's not 4 already. It's 2 na lang siya. Okay? So, square root of, okay, 2 times 4, 8. Okay? And then divided by pi. Okay. So, 8 divided by 3, charot. 8 divided by 3.1416 is equals to square root. Okay? So, 2.54 siya. Okay? 8 divided by pi, square root. 8 divided by 3.1416, square root. So, 2.55. Okay, 2.55 meter. Okay? Like that. Again, ano nga ito na square root? Because you have to multiply with 1/2 each man siya to cancel the raised to the power 2. Okay? Like this. Okay? So if this is like this, okay, by the d2 over 2 over 4 is equals to 8, then multiply like that. So it's gonna be by the b to 8 siya. So db, ganun siya, is equals to 8 over pi, square root siya. Kaya gi-raise man siya both 1/2. Ganun siya, oh. Gi-raise siya both 1/2 man siya. So, makancel siya ang 2 sa exponent. So, this one, this quantity here will be the square root of 8 over pi. So, we have 2.55 meters sa point B. This is our diameter B. Okay. Diameter B and diameter A. Now, what you will use for this? Okay. You will choose what diameter you will use. It could be in the point A or point B. Okay? Because you will never subtract the diameter. Okay? Take a look. If this is a horizontal pipeline and it will change the diameter, so the water will flow there. So the reference point already is in the final stage diameter. Because it's in there, the flow going to the output. Okay, it's not also in the theory that we need to subtract the diameter inside and diameter in the second. There's no theory in that manner. There's a theory that outside diameter minus inside diameter, okay, like a thickness, okay, but thickness of the pipe, okay, the thickness of the pipe, right? We can compute for the inner diameter and for the outer diameter. But here it's not an issue because it's only an issue for insulation problem. Insulation problem, thermal conductivity, okay, heat transfer or thermodynamics. K, thermal conductivity. But here it's not an issue. Our diameter really is really the one basing on the outer. I will show you, ha. Okay. Kuan man. Diba na siya thickness gamay, ana? Okay. So, diri man gud siya inner diameter. And here, outside diameter. I will show you this one, right? This is the pipe. This is the round entrance of the pipe, right? There's still a thickness of that pipe. For example, the pipe is made of bronze, zinc, copper, like that, right? Or alloyed with zinc, something like that. So it's coated with blah, blah, blah. So there's a thickness here, somewhere here. So this here and here is the outside diameter of the pipe. And with the inside diameter. So we are focusing in the inside diameter because it's in there, the fluid will go. It's not on the outside diameter or else the water will escape. You understand my point? It's the inner diameter will be considered, not on the outside diameter. Because in the inside diameter here, it's in there that the water will flow, not on the outside diameter of the pipe. Outside diameter of the pipe or external diameter of the pipe is bigger than internal diameter of the pipe or the inside diameter pipe. Now, in Reynolds number, we use the inner diameter pipe, okay, and the inside diameter. So that's we are looking for, not the outside, okay? Just to make it clear, okay, because there are two diameters in a pipe because of the thickness of the metal covering or the coating of that particular construction of material. Let's say zinc, copper, bronze, stainless steel, ganon, right? So inner diameter ta. Okay, so we need to say these are all both inner diameter, the DA and DB. So we don't need to subtract that one, okay, because that's the difference of the diameter. In the Reynolds number, it will go to the last point. So it's in there, okay? So we need to use the DB, okay, the DB diameter, because it's in the last stage that the water will flow, okay? So it's in this point B. Diameter B inside will be used, not here, okay? So it will just focus there, right? This is the final, okay? No need to subtract, because if you try to subtract, your value will become small. It's impossible, okay? Like that 2 point something, there's no point something here, or else the flow is very less, okay? Something like that. So this is basing really for the diameter B. So the diameter B we will use in the Reynolds number L, okay? So referring to the length of the diameter. So substitute that in the point B, not the point A, okay? Though the difference is only, let's say 2.55 minus 2.25 is equals to, like this. Oh my gosh. The difference is something lang siya. Use na lang 2.55, the point lang siya. It's impossible for Reynolds number to have the point diameter, okay? And by analysis also, we need to use the diameter at the second point, because it is where the last flow will be going there to establish laminar flow. Okay? Laminar flow man jud siya. It's not turbulent. Okay? Ganon. So substitute na ta para walay lubog. Okay? So again, saan naman to makalagot? Okay. Saan naman to kung gisot suwat? Char. Oy. Hello, where are you? Nawala. In fairness, nawala gid siya. Dito pala. Hindi na mauwi. Fairness. O, usbon lang nako. Ay nako. So Reynolds number is equals to the length, which is 2.55. Nakuha naman, di ba? Sige. 2.55. Density, 1,000 gihapon. Velocity, at the point B also. Okay, because I'm using the diameter of the point B, then use also the velocity in the point B. Okay, understand? To make it short, to make it safe, we will compute one by one for the Reynolds 1 at point A, Reynolds at point B. Let's just make our own analysis, though it's not being discussed in the, in the theory that you're gonna separate the Reynolds number, because most of the time the flow is just overall as a Reynolds numbers. Our purpose only is to quantify really our analysis if we having a correct analysis. Okay, let's do it individually na lang siya to make it sure. Okay, and then 10 over the viscosity. Ato na siyang i-convert, di ba? Viscosity, absolute viscosity man to siya. Okay, 0.00. Mahibaw ba yan nimo kay kung gamay kaayo, di ba? So wrong siya. Okay? Basta ganito, Reynolds number is less than 2,000, right? Maximum 2,100 at a maximum velocity. Now, turbulent 4,000. Then if you obtain too much like this, so this is wrong. Okay? Because it's turbulent and Bernoulli will not applied in the turbulent. So makulbaan ko, chart. So 2.55 times 1,000 times 10. Ano na ni Ron? Divided by 0.001567 Okay, like that. So 2.55 times 1,000 times 10 divided by 1.5673, right? 1.5673. Ala, 16,270 ang Reynolds number. So this is turbulent. So this is wrong. Okay? This is wrong analysis. Okay? This is wrong because we can obtain a turbulent. This is laminar because we're using the Bernoulli Theorem. So another. Okay, another. We will use the total diameter, which is 2.25 plus 2.55. Or kay length man siya. Okay. Okay, 2.55 plus ganun. Sama to 2.25. Okay, times 1,000 equals to divided by 1.5673. 3,062, almost closer to 4,000. Unsa man ni siya? Okay, 2001, like it is transition stage siya. Di pag siya laminar. Right? 3,062. Because ang transition flow man siya good kay 2,100 to 4,000 ang Reynolds number nimo. But I obtained a Reynolds number which is 3,062. This is still transition stage going to turbulent. So it's still wrong if you add all the length of the diameter A, diameter B. So let's go back inspection of the viscosity. Maybe we are using the wrong formula for the viscosity. Okay. Viscosity is kilogram, per meter second. So this one. So let's put that in this way. Okay. So 2.55, 1,000. Mauna akong ingunin nyo na, the unit is very important. Okay. 4 times 10 times 2.55 is equals to divided by times 2.55 is equals to divided by 0.001567 is equals to taas gyapon kay siya 3,000 something. Oh my God. So something, di ba? For example, if this is an actual examination, I don't really solve ahead of time. That's why. So I did not prepare it prior to solve. So the on the spot solve. That's why. How can I justify this? Wow. Hello, June. Sige pa. Okay. Reynolds number. So in this case, class, if we think that, oh my God, it's very, I'll teach you something. It's not really logical that to have 3,062. Okay. Now, and then if there's in the choices there, it's very near, then go to the very near one. Okay. You don't have to go back with your solution because it takes time. Okay. And then you will consume all your time, then problem to focus only in one question. In this case kasi, I obtained 3,062 and then 4,000 man ang turbulent. And then the best way to this is to do interpolation na lang, di ba? Interpolation. You can remember that interpolation? Okay, so let's do this. So, let's analyze na lang kung asa siya pabor. Okay? Because transition man siya, so it could either be pabor siya sa laminar or it could either be pabor siya sa turbulent. Okay, let's do the interpolation first. Okay, so 3,062 minus 2,100. Ano na lang siya? By logic. Okay? Because na-fail man siya sa theory, di siya exact na below 2,100. Nilapas good siya, 3,062. So if you do the interpolation, we obtain 962 difference from the laminar. Okay? Ako na lang ni siya ha. Because, you know, okay, that's why in Transport Phenomena, I read some of the discussion there that it really needs imagination sometimes, and logic and critical thinking, because sometimes it's not really meeting the ideal, on the problem solving that we have. Logic and, a little bit of analysis and common sense na lang siya talaga, di ba? In this case na we did not obtain an exact value closer to the Reynolds number, now we can say laminar siya. Okay, but for the other theory, no problem anymore because it obtained the continuity law, the law of conservation of energy, perfect talaga siya. But it is Reynolds number na lang siya that deviates. Okay, 962 siya reference from laminar flow. Now, we need to interpolate also from the turbulent flow. So we have 4,000. Okay, minus. Okay, so 4,000 minus 3,000. Ano natin siya? So x, ganito ba yung interpolation? X, i-show na ko para maklaro. X is equals to 3,062. Okay, and then 4,000 minus 362. Okay, like that. Okay, and then for the Reynolds number, like that. So solve for the value of x. Charot. Algebra pa din. 4,000 minus 2,100 is equals to 1,900. Okay, x 3,062, 1,900. X is equals to 3,062 minus 1,900. 1,162. Sure. Again. Kaya ang ano ba siya? Less than ba siya sa 2,100? Laminar ba siya? Okay, let's check again to make it safe. Okay. 4,000. So if we have this level maximum for turbulent, okay, nag-analysis si June. Turbulent, so this is 4,000. Okay, laminar is 2,100. And you get the Reynolds number, which is somewhere along the center. Okay, center, which is equal to 3,062. Okay, now put that here. So 4,000, okay, minus 3,062, okay, is equal to here 2,100 minus x. X, ba kaysa 2,100 x, okay, is equals to my goodness, 362 minus 4,000. Okay. Okay. Yes. Okay. The negative x, no, negative yun kaya siya. So, 3,062 minus 4,000, negative 938. Okay. 938. Negative 938. And then, negative 2,100. So x will be equal to 938 plus 2,100. 3,038. Even turbulent, somewhere along so that we will satisfy for the theory. Okay? Never mind, we'll go to another question. At least siya turbulent, di ba? Okay? Like this. So, number 4, volume. Mugubak siya, dito mo N, kung hindi na ito makompute. Charot! Number 4. Lagi. So, work is equals to the change in kinetic energy. Theory again in the transport phenomenon. Actually, this is physics. Okay? Then we try to adapt in transport phenomena or in the momentum transfer or the fluid flow. Okay. Work is equal to the change in kinetic energy because there's a covered distance for this motion of the fluid going into horizontal pipeline, right? So, okay, work is equals to the change in kinetic energy or delta change in kinetic energy. Okay, ganon. Okay, work is equals to the delta change in kinetic energy because there's motion. There's no issue for the potential energy, ha? Okay? And then, work. So, nandiyan na naman tayo sa work. Okay? So, work is equals to force times distance in physics again. Okay? Like this. Force. Exciting kayo, no? Kayo na yung mga remaining, we have to prove. Okay. Work is equals to force times distance. Okay? Then substitute that here. Okay. Force times distance is equals to delta change in kinetic energy. Okay? Then change in kinetic energy is equals to final kinetic energy minus initial kinetic energy. So in here, point B, point A. So 1/2. Mamani yung formula sa kinetic energy. Ayun mo kalimot, ang formula sa kinetic energy is 1/2 and velocity squared yun siya. Kanunay. Forever and ever. Amen. Ganon. So, 1/2 mu squared. Ay mo kalibog ang u velocity na. I just left that as velocity in my solution. So, 1/2 mu squared. Substitute that here. So, point B. So, 1/2 MUB. Ganon. Or MB UB raised to the power 2. So, this is a change. This is kinetic energy difference from final to initial. So, minus 1/2 UB, charot. Like this, okay? Okay, ganun lang siya. Isa siya. Tapos, ang force there, guys, is the net force. Meaning the total force from point A to point B. Net force. Okay. Why inertia, ha? There's no inertia involved here because there's no such opposing forces. Okay, the flowing of the liquid water going to the outlet. Unless it's specified that there's there's a resistance, blah, 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 and there's a fraction, ganon. It's not stated there. So there's no blockage, there's no fraction after all in the flow, okay, going to the, counteracting to the flow of the fluid. So we just put that net force. So supposedly we would say force A plus force B is our net force. Okay? Like that. Now, since we are not concentrating more on the force here, okay, we are concentrating for the pressure and the velocity. So think of a formula that it involves a pressure. Again, physics. Pressure is equals to force over area. Okay? Now, solve for the value of F. So pressure times area. So substitute put in the net force. So pressure times area. Okay? Pressure times area times D. Okay, like this. Ay kahadlok. Okay, pressure times area times D. This force is equals to pressure. Sa formula sa physics nga P is equals to force over area. Now, the D is the distance covered by the fluid from point A to point B. Ganon. So, this could also be equal to the length of the pipe. A horizontal distance man siya. It's not vertical. Okay? So, distance A plus distance B is equal to the total distance covered of the fluid flow in the horizontal pipe. So this is the total distance also, because you treat also total force here. So this must be consistent enough. Okay, like that. So this is dt. Okay, dt total. Okay, like that. Now, investigate the unit of distance, that is meter. Because all we'll be dealing with meter here. Metric kasi. Okay? So meter. Area also is square meter. And pressure, what is pressure? Okay? Pressure is Pascal here. That is Newton square meter. Okay? So it agree because it also matter in the denominator, right? Okay, so now pressure times square meter times meter. Okay, ato mo yung gipugos because we need to force this quantities here para maano siya, ma-simplify talaga siya. Okay, so equal to this one, the changes in kinetic energy. Now, if you multiply the square meter to meter, di ba, cubic meter? Also, cubic meter is the unit of volume. Think. Cubic meter is a unit of volume. And it's also a unit of, yes, volume. Cubic centimeter also, like this. If raised to the power 3, automatically it's a volume. Okay, blah, 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 so So that become V. So replace that with capital V, volume. So this will equal now to pressure times volume is equal to the change with kinetic energy. So PV na siya. Naging PV siya, imagine, from this, name mo PV. Now, since this is really talking about the changes, the delta change, so put delta change, this is really talking about the changes, the delta change. So put delta change and pressure times the volume. So this will be equal now that change and pressure, and now that change and pressure and volume is equal to the change of kinetic energy. Now substitute values here so that we can compute to letter C. Ano mo itong letter C? Oy, sige pangita ato, nakalimot ko. Chart. Okay. Asa naman to? Talaga? Pero total volume, no? Kita, no? Oo, total volume siya. So, klaro kayo siya. Oy, na makuha na yun mo ang volume. Okay? Yes. Now, mass man siya here and this squared. So, there's also a formula. Density is equals to mass over volume, right? So, since this is a mass, compute for the mass. So density times volume. So, let's make it here. So maglibog. Density is equals to mass over volume. So mass equal to density times volume. Right? Like that. Okay? Density is equals to mass over volume. Okay. So substitute the mass. Okay? Like that. Here. So 1/2 times density times volume A times velocity B minus 1/2. Grabe siya. Density A V. This is what the complication comes in. Okay. Then squared like this. Then VAUA. Diba? Ganon. Oh. Tapos naka siyang quantities. Okay. At mag-incorporate ang volume sa density. Here. So, isolve mo siya diri sa M. Density times volume. So, density A, volume A. The same also with here. Density A, volume A. So, delta PV is just like that. Okay. So, na siya V. Right? So, this is equation 3, diba? At sa i-simplify, oy. Para mahimo na na itong equation 3. Wow. So, delta PV is equals to sudlan we should not substitute first because we don't know the volume of A in the point A. We should not also know the volume coming from the point B. Okay? So that we can get the total volume. Okay? So as is lang muna yan, ganyan siya. Okay? So, 1/2 density A. Oh my gosh. Volume A, velocity A raised to the power 2 minus 1/2 density B, volume B. Okay, then UB raised to the power 2. And then delta P is P2 minus P1 man siya. So namatay pressure, di ba? Nakuha na siya, di ba? Asa man to, oy? Oh, sige. Atong pressure is initial is ano man siya? 300,000. So 300,000 minus initial pressure na 300,000 minus ano siya? Pila to? Okay, pila to? Pila to pressure, oy? Nakalimot ako. Na siya, 262,500 siya. So, ano man siya? P2 minus P1. So, bali siya, 262,500 minus 300,000. Right? Like this. Okay? So, since balisad siya, this is P. P sa nang mag-una. Kaya final man siya. Okay? Let's make consistent, ha? So, hindi na tayo mag-cancel-cancel sa mga units o sa mga signs. Okay? Like that. Ganon. Uy, di yun maklaro ay. So, kanya siya 3 B ni siya ha. 3A kaya ano, final man siya. Kinetic energy final minus kinetic energy initial man siya. Delta change in kinetic energy man siya. Okay? Like that. So, ako lang klaro kay kuwan tayo. Pinapasan. So, 1/2 times density B, VB, UB divided to 1/2 density A, volume A, and UA raised to the power 2. Take note guys, mayroon na tayong velocity ha, di na tayo magproblema. Kaning UB o UA. Nasa tayo density. Okay? Nasa tayo density. Ang ating problema na lang jud no is ang VA and VB. Okay? Naman tayo V total V ha. Okay, so total V is equals to VA plus VB siya ha. O nag-create na sa equation. Like this. Makaingon na sa ko, may pag-tanaw lang na akong solution para makuha na ko ang correct answer. Ganon. Okay? Like this. But the problem is I don't practice the solution, that's why. Okay? So, total volume is equals to VA plus VB. So, kung makuha niyo ang VA and VB, then we can project the total volume which is being asked on the problem. Now, asa man ito makuha ang VA o VB? Nakakaloka, no? This is equation number, siya ha, number 4. Saan may kinuha equation? Equation E. Density is mass over volume, right? Mass over volume. Right? Volume. Yan na density. 2 times, right? That's an industry. Sorry. 262 times 500 minus 100,000. 500. Then 25. Ang MV, kay density man na siya. Butangan din mo siya density. Okay? Negative 37 plus 500. V is equals to 1/2. Kay density man ni siya sa akong ingon. Okay? So naman tayo density 1,000. Okay, so makuha na yun siya. So 1,000. So this is our equation number 7 ha. Okay? So 1,000 times 100 minus 1,000. So 100. Grabe. Buwis buhay. So, 25, 100, di kabayran. Okay, divide by 100 times 25 divided by 2. Okay. Naa siya ikuan ha. Ato ni klarohon kay murag naglibog. Ang inyong instructor na libog sa because dagat kay mga equations. Imagine equation number 7 na tayo. Okay? B. Okay. Kaloka. So, mo mo dyan i-permit sa mga examination, may taon dyan siya. Wow. Ay nako. So, 100 times 1,000. Okay. Minus, again, we substitute na already. So, 25 times 100. Okay. Okay, kung bright pa lang dyan kung math, dali na kayo ni siya. Okay, di mo ko bright of math. Charot! 25 times 1,000 divided by 2, 12,500. Okay. Still, I can understand and comprehend, but lahi mo dito taas yung IQ ba sa math kay na yun. Ako, I just try to, to be detailed, accompany with the concepts and theories magod ko. I work more on the theories and concepts magod. Okay. Okay, secondary na lang ng formula. Okay, 12 minus 12,500 over negative 37,500. Okay. So, i-reverse na to siya, P2 minus P1. Okay, ang P2 na to is 262 man, munong negative sign siya. Okay, just forget it for the meantime. Okay, 50,000 negative sign siya. Okay, just forget it for the meantime. Okay, 50,000 minus pila na ito eh? So 262,500 minus 200,000. What siya? 37. Ganun siya naman kay volume, di ba? So, ganun siya. Charot. So, divided by 37,500. Okay. Is equal to 50,000. Nag-ipuno ko sa calculator. Okay, 50,000 minus 12,500. Pas sa kayo divided by 37,500. Okay. This is equal to 1. Okay? Like this. Okay, volume. Negative 1 is a wrong assumption. So it's wrong. Okay? Like this. It's wrong. So what? Grabe ha sa A. Daganang equation A. Okay? Muna mong word. Okay? Muna mong word. Okay. Now, go. Ganun. Okay. So, ang VA na naman ta siya, ano na ta VA? So, delta P, pressure V. Okay, over 37,500. So, we have volume, density. We'll go back ta sa density. Okay? Okay, like that. Volume, mass over D. And we have the volume is equal to negative 1. Wala, may ganun, June. Okay, negative 1. Okay, is equals to the mass, and density is 1,000. So actually, your mass will be also equal to 1,000. But in terms of kilogram. Okay? Like that. So, density, mass over volume. So, substitute that here. So, 362,500 minus 300,000, okay, times V, okay, is equal to, pila man imong kuha, 37,500. So ang mass nimo is 1,000 kilogram. But you are after for the volume total. Okay, so go back to equation 4 here. Okay, kailangan tayo VA, VB, okay? So, volume total will be equal to VA mass A. Density mass over volume. Mass 1,000. 1 plus 1 volume is equals to total volume equal to 2. Total volume is equal to 2. Okay. 2, but that is 1,000 kilometer density. So 1,000 kilogram. 1,000 kilogram, pila man na siya ka volume. Okay, nakakuha naman butag mass na 1,000 kilogram. Okay, na naman kayo mass abuna. Okay? So, natayas, no? So, volume density equals to mass over volume. So, para mahimo siyang volume, so, go back ka sa flow rate. Charot. Okay, para makuha mo ang volume, right? Okay, so, 1,000 kilogram, okay, times kilogram, cubic meter, cancel. Okay, ganon. So, mubalik siya. So, 1,000. So, equal yan po siya sa 1,000 cubic meter. Okay? So, the mass is 1,000 kilogram. Okay, and the volume is equal to volume A plus to 1, right? Density of water. Okay? So, ganon. Grabe ako, equation number 8. Number 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, going back to the distance na, nakuha naman nato ang kuan, ang volume. Distance. So, ito pa ko ang distance. Okay. Balik tano sa equation. Na-solve naman nato siya. Ano to eh? Madari. Distance. Okay. So, distance, pressure times area, and then divided by this thing. Okay. So, substitute na siya balik. Using equation number, kapila na ito nga equation. 3. Okay. Guys, grabe siya, no? Okay. Density, total. DT na siya total. So, imo naman na siya substitute. Ano makita 37,500, no? Okay. So, divided by the, the pressure na imong nakuha. Okay. Pila may mo nakuha na pressure? So, 300,000 minus 2,625. 300,000 minus 262,500 is equals to 37,500. Like this. Okay, distance A plus distance C. Okay, so velocity is equal to distance over time. Velocity is equal to distance over time. So time 1 is equal to time 2. Charot. Okay. Time 2 is equal to, so this will be equal to V1, T1 is equal to distance, then T1, distance over V1. Okay, distance A over VA. This, okay, and distance B over VB. Like this. Okay? Naman tayo velocity. So distance A is equals to velocity A, 5. Distance B, velocity B, 10. Okay? like this. Okay. Now, solve with the value of A is equals to dB, okay, 10 and 5. Okay. Now, dB5, dB5, okay, over 10 plus dB. Okay, so that is, pila man siya? 5 divided by 10, okay, plus 1. So 1.5 dB. This is our distance B. Okay, like that. Okay, so our distance total is equals to 1.5 dB. Kung nakakibaw sa dB, isolve na sa timo ang dB. Okay, dB is equals to velocity. Okay, velocity times time. Like that. And then here, the time is not an issue for the laminar flow. Okay, like that. So, our total distance covered is equals to 1.5 times the distance of B. Okay, like that. The total distance is equals to covered is equals to 1.5 the distance of B. Okay, here. Okay, so let's go back. Asa naman to? Equation number 9 na ni siya ha. Equation number 9. In terms of distance is equals to 1.5 dB, di ba? Nakuha na siya. So 1.5 dB. Okay, and then negative 37,500. And then is equals to 1/2 so density mass over volume, mole mass is equals to density times volume. Okay. Naimo sa nang substitute ang volume here. Nakuha lang sa nato ang volume here. Okay. Sa primero. But never mind, just put the mass because we also solve the mass. It's 1,000, right? So 1,000. So V squared 100 2 minus 1 to like that. And then 1,005 squared. Okay. So you can compute for the value of dB. Pila man ni siya. So times 1,000 divided by 2, 50,000 minus 12,500 divided 37,500 times 1.5, 5,650. So 50,000 minus 12,500 divided by 56,250. Okay. So this is dB is equals to dB. Excuse me for a while. Okay. Wait ha. So this is times 1.5 na ni siya ang dA. 1.67. So times 1.5. 1. dA is equals to 1. Okay. 1 plus 0.67. 1 plus 0.67. 1.67 meter ang total distance, guys. Total distance is 1.67 or the length of the horizontal pipe. 1.67 meter. Taas kay siya, no? 1.7 mga, kasi mataas siya. 1.67 meter. Okay siya. Right? Okay siya, 1.67 meter. Ang iyang, the length of the pipe is 1. Too much, right? Okay, compute na nato lang. Volume total, distance total, dA, point A plus dB. So nakukuha man tag ratio ana nga d total is equals 1.5 dB. And then that dt is substitute man pud siya sa distance. Siya kina-compute naman tag mass nga 1,000, right? Assuming nga ang density maora gyud siya Fermi. Okay? It doesn't change kay water man gud siya. So constant man ang density. Pipe 1.67 meter lang gud siya ang example. So wala siya. So nika-solve na to ana niya kay naman tay pressure times A, di ba? Times total distance. Okay? So muna na imong work. So para makuha siya na to ang volume kay mo man nang kalagutan ang volume kay na negative man to siya, na wrong assumption ba yata, mubalik ta sa volume. Okay? Okay, somewhere along the way, naatay analysis nga volume, wrong ang atong answer. Limang kag negative 1 volume, it's not possible, di ba? Okay, so we need to go back. Okay, so work is equals to change in kinetic energy. So based on our computation, na naman tayo kinetic energy nga 37,500 na base ni substitute na nato siya tanan. So ano siya 37,500. We have value of the mass, with the value of the velocity. So change in energy will be obtained. So this is the what we get in the change in kinetic energy. Okay. Now our distance is 1.67 meters siya, diba? So wait for that. Okay. Work is equals to force times distance. Okay. Ang kaning D, total distance 37,500 divided by 1.67. So mo na imong force. Sotero, why you compute the force? So that we can obtain also the volume later on. Right? 37,500 divided by 1.67. Our force is 22,455 ano siya, Newton. 22,455 Newton is siya. O, na natin value sa force. Okay. Now, W is delta PV man siya. Okay, delta PV siya. We have 37,500. Okay. And we have the force of 22,000. So, this should siya nga pressure, blah, 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 blah. Okay, but this is a change man good siya. So, individual pressure will be obtained. Oh, di ba? Individual pressure siya. P2 minus P1 minus siya times V is equals to 37,500 man siya. So, individual pressure will be obtained para makakuha tag volume. So, atong i-tagsa-tagsa ha. So, pressure is equals to force over area. Okay? Like that. So, okay. So, pressure 2 is equals to force 2 over area F1 over A1 times volume is equals to 7,500. Okay. O, 2 siya. 2, and then this one is 4. Is equals to V. 7,000. Okay. Now in here, okay, total man is siya, so that is F1 plus F2. So we can solve for the value of F1. Let's say lang siya ha. So F1 is equals to 22455 minus F2. Okay? Substitute that here. So F2 is equals to 2 minus F1 27, 22, this is 22, it is 27, 22,455. Okay. Minus F2. Okay. Over 4. So V will be density mass over is equals to mass over density. Okay. So, kailangan ang atong volume. So ato na nang i-divide. Calculator, V. Ganun ba? Okay. So, this is 2.2455 V4. Then 1 divided by 4. 0.25 F to V. Okay, so common ang V. Okay, so this is V.5 positive 15 V. Hindi na nabigin. Ako naman siya. So this is so kung ang ini mo siya, okay, V is positive, negative siya, negative set siya. Okay. Wala na siya F2, V siya F2. Okay. So this is gonna be like this, 0.5 V. So i-add sa nila mo mga V, 0.25 F2. Okay, and then minus 5,613 V. Okay. Number 10. Okay. Equation number 10 na siya. Okay. So total volume, as naman ito? Total volume. So total volume is equals to, di ba, pi d squared over 4 plus flow rate. So U1, density 1, area. So you can solve for the value of, so there's no volume here, since this is area. Okay, so you need to find another value for the distance for that. Okay, so pi d squared over 4, area na siya daan, times distance. Correct? Okay. Naman tayo distance nga. Pila to tong distance per mero? Nakuha naman to, di ba? 1.67. This is distance total. Saan naman to kung nakuha na to siya? Equation number 10. Sobrang daming equation, no? Nakakaloka na. Okay, ganun talaga siya. Okay? So, not yet batake. Kuha yun na itong volume. Ang volume na may, napaday Reynolds number. Okay, nilapas man sa 2,100. Transition stage ito. Nakuha na itong ko'y kuan, whiteboard na lang. Nagkalibog ako na asa na ito siya nakuha. Gagara na natin i-prove ato nga something di ba? Anong nga 4.67. Kaya magamit maguto siya. Asa na ito? Okay. Okay. We need to trace that one. Okay, nakuha naman to ang 1.67. Total distance. At one. Diba? So, total distance, nakuha na siya. Total distance is 1.5 dB. So, nakuha siya nga 1.67. Atong dt. So, ang atong dB, so dt is equals to 1.67. Ang atong dB, 1.5 dB. Atong dB kay kuan. I-divide na to siya. 1.67 divided by 1.5. 1.11 ang atong dB. Yeah. Ang atong dA, so dt, 1.7 minus dB. 7 minus 1.11. So atong dB is 0.56. DA 1.56 para mahimo siyang kwan. Wala na siya. Gamito na nato siya diri. Okay? So, ito na-compute na here. Dire. Okay? Sa volume, ang total volume is equals to pi d squared over 4 times force times distance. Force, pressure times area. Okay? Times distance. And now, we have the area man siya. And the distance, you can obtain a unit of cubic meter man siya, di ba? Okay. So, atong total distance na gamiton is 1.67 ha. Timo man na siya ang total length of the pipe. So, like this. So, dapat pala, gamiton sa demo, second point will be used for the total volume. Okay? Or the diameter 1 and the diameter 2 to make it safe. Muna siya ang area. So, area 1 and area 2. Sa tagsaman siya. Okay? Okay. Naman tayo diameter per meron nga niya sa pipe is pila to siya itong drawing. So, that is ay nako. Okay, so diameter 1 man gyud siya. Area 1 is 4 man gyud siya. Okay? So, this is D1 okay, nato. 0.56. Ang work nato kinasad kay 37,500. Nakuha naman sa dinato siya. Kay change in kinetic energy naman siya. Okay? Ganun talaga siya. Kung yun lang mo ito sa tagsa jud. Okay? 3.14 divided by 4. Okay? Times 5 equals times 0.56 equals to atong diameter 1 is equals to diameter 1.58. Diameter 1. Diameter A is 1.58. Okay? Atong i-add yun. Okay? So, diameter 2. So, 10 man siya. So, 0.56 times 10 is equals to 3.1416 divided by 4 again times 510 times 0.56 4.384. So, ganun siya. So, i-divide mo siya 4.389. So, 37,556 yan. So, 1.67 minus 0.56. 1.11, oy. Charot. Okay. 1 naman ta. Distance 2 naman ta. Okay? So, 1.11 times 5. 3.1416 divided by 4. Okay? Times 100 times 1.11. 8.7. Okay, like this. So the diameter is 2.199. Like this. Diameter A. So isubstitute naman mo na siya. Okay? So diameter 2. Okay, and diameter 1. So we have, kaya naman kaano. So isubstitute naman siya dito. So magkuha na sa bikas. Okay. So 5. Okay. And then somebody siya is 4 man siya. 4 siya. Okay? And then the distance is ano siya? That is 0.56 equal to, okay, 10. So pi d2 over 2 over 4. Then times 1.67. The d2 now here. Okay? pila siya. So 13.11 d b squared. This is diameter, ha? So 20 times 0.56. 20 times 0.56 equals to 11.2 divided by 13.11 to square root equals to. Okay, the diameter in B is 190. A 1.58. Diameter is 0.92. Like that. Hindi mo siya i-minus. Okay, i-add mo siya ang area. Area 1 and area 2. Saka muna. I-minus na siya. I-minus siya. Okay, isulod mo siya dito. Okay? So area 2 minus area 1. So that is 2. 3.34 cubic meter. Okay? Pero kung tagsa na, gapon mo siya, pwede rin po siya. Kuha mo na kung diameter sa tagsa. Okay? So, this is 2.99. Pila itong usa. Actually, hindi mo necessary you did not necessary to get individual diameter, ha? Because area naman siya, area times distance, naman siya cubic meter. So, pwede na siya, you don't have to solve the diameter each. Okay? And let's record for the diameter. So, we have 3.34 cubic meter. Asa na ito siya, oy? Itong ipangita. 3.34 cubic meter. So, kung cubic meter siya, i-convert din na mo siya o kuan. Volume into liter, into milliliter. Okay, but this is cubic meter because of our units. This density is kilogram per cubic meter. 3.34 cubic meter. Ang volume, isulod ito siya. Oh. Saan na ito ako ipangita? Uy, nakakaloka, di ba? Kaya makalibya siya pero lang papel, di ba? Naluloka ako. Yung mga na yung mga required, yung gano'n, whatever, chupa-chuchu. Ito. So, 3,000 ang Reynolds number. And then, volume is, total volume is 3.34 cubic meter. On answer na nakatanan, ha? In these questions, a lot of required. It took a lot of formulas to solve, and we derive something like that. There's no such specific to determine the exact, especially in number 4, number 4, number 5. There's a lot of equations to be used compared to 1 and 2. Good only that it's gonna be in 1 and 2, but there's 3, 4 explore some theories. If the Bernoulli theory is still applicable to transition stage. Right? Because it's applied only in the steady state flow and laminar flow. But this 3,000 is somewhere in between kasi siya eh, to 2,100 and to 4,000. So that will be your assignment. O diba? May ganon. My question now is 3,000 Reynolds number is applicable to the Bernoulli equation or no longer applicable? Something like that. Okay, because based on the theory, it's only laminar flow that follows the Bernoulli theorem man siya. Okay, we have no more time to investigate. So investigate natin siya uli. It will just be simple. Last, okay, using Reynolds number. Okay, ilast na to siya to prove really that Reynolds number is less than 2,100, right? Para maglaminar siya, kaya mo gina siya ang Bernoulli theorem. Okay? So, nisupak man ta based on auto solution. Okay? Naka-obtain naman tag 3,000. Transition stage, bayan siya. Okay? Ganon. So, okay na siya. So, siguro I have the whiteboard. So, di ko maglibog. Actually, naglibog ko sa mga suot-suot. Kaya nagamit ko. Okay, see? Okay. Wait ha, mag-Reynolds number sa compute. Wow. Talaga. Reynolds number, length. The length here is what is referring is the circle length siya. So equal to the diameter siya. Inside diameter of the pipe. Okay? So to make it sure class, we need to individually compute na lang siya ha para sureness yun talaga siya. Okay, diameter 1 and diameter 2 from point A and point 2 para sure siya. Okay, so diameter 1, kay kuan man to siya. Okay, is equals to density 1,000. Area 2 nga kuan siya ni sa 2 ba to siya? Ang lisod sa, okay, di naman ang problem, no? So, ang 2 square meters siya. Velocity is 10. Ganon. So, for D1, okay, 10 times 2 times 1,000. 20,000. Kani siya, 20,000. Okay, D1. Dito na ako ha, kay mora man Japon good. Okay. So, 5. Sabot, bitaw mo? Wow. 1,000. 3.1416 divided by 4 is equals to times 5 is equals to times 1,000 to 3927. 927 is equals to the square root. So, D1 is equals to 5.09 meter diameter. So, Reynolds number, substitute D1 here. Okay, mass flow rate. We can compute for the density 1 through the mass flow rate. Diameter 1 for the density. Okay, density 1, A1, U1. Okay, U2, density 2, A2. You can compute for the diameter 1. So you can compute also for the diameter 2 later. So we need D1 substitute here. Okay? So 5.09 raised to the power 2. Let's investigate. Times 1,000. Pila na itong Reynolds ani? Divided by 0.0.01567.3. Okay? So 5.09 times 5.09 times 1,000 times 5 divided by 0.0015673. Okay, 5.09 times 5.09 times 1,000. 5.09 times 5.09 times 1,000 times 5 divided by 1.5673. Oh, this is very big. This is 82,652. This is wrong. Turbulent. Turbulent. Okay. Turbulent. Number 2, Reynolds number. So you have the D1 here. D2 na sa top. Okay. So, substitute the 5.09 here. Okay. Bali. So, dito na sa datong computon. So, D2. Okay. 5/4 times 10 times 1,000 is equal to pila na sa da siya. So, 5.09. Okay. Then 5.09 times 3.1416 divided by 4 times 5 times 1,000. Okay. 101,741. Okay. Now, so 3.1416 divided by 4 times 10 times 1,000. Okay, 7854. Okay, 101,741 divided by 7854 is equals to square root 3.6. Diameter 2 is 3.6. Diameter 1 is 5.09 and diameter 2 is 3.6. Okay? Now, solve for the total volume. Okay, we have the area pi, okay, times 3.6 plus, 5.09 is equals to, charot. Ganun siya, di ba? Ganon. Ganon. Tagsa-tagsaon lagi yun siya. Okay? Tagsa-tagsaon siya pagkuha sa diameter. O, lagi na siya 5.09. Okay? Ganon siya. So, taas gid kayo siya. So, 3.6. 3.6 times 3.6. What? Really? Oh, sorry, it's not squared. Mo rin taas kayo. Okay. 5.09 times 1,000 times 5 is equals to divided by, mura mo gud gapon, 1.5673. Mo gyapon ay 16,000 taas kayo. Turbulent gud siya. In this case, it's turbulent if you will get each individual diameter. How much will you will add the two diameters for that? Because in Reynolds number, that is the diameter. Okay? And I don't know how to explain this one also. Okay? For yes. Okay, just okay, the Reynolds number, calculate the Reynolds number, this question. Here. Number 3 question. Okay? So we obtained first 3,000 and then we individually computed it's more than turbulent. But this one, first computation is transition stage. Okay? So that's it for problem. Water flows through a horizontal pipeline with a 4 degrees Celsius at viscosity of 1 millipascal, okay, across a sectional area of 4 square meter with a velocity of 5 meter per second. With B, so the velocity is 10 meters. Calculate the pressure at the point B. The pressure is 262,500 pascal. Okay. Calculate the Reynolds number. What's the total length of the horizontal pipeline? So it is 1.67 meter. Okay. The only problem is the Reynolds number. Okay. Like that. Oh my gosh. Too much. Thank you so much for listening. This very lengthy problem solving. Okay. Information. But the most important is really you will use that equation following the theories, and then if you will be confused, stick to the formulas that being presented in the theory, okay? And the analysis later. Like especially if the question is multiple choice, you can easily adjust your answers there. Okay, like that. Okay, this is the technique, and just go to the closest value of the you get that answer and very close to the choices, then go there. Okay, because theory is easy to it's easy to guess. Theory questions or concepts questions, or it's very easy to get only the problem solving. Sometimes your answers will be a little bit far from the choices. I hope you like it. Charot. Okay, if you didn't subscribe yet channel, you can subscribe. You can click the notification bell for some news updates of Missing Eternal Voice. Thank you so much, guys. Bye bye, everybody. God bless.